Assalamualaikum. My name is Adam Iqbal Han and my metric number is 825CS0171. So I am in charge of doing the workload for A and B using the Windows suite, which is HWiNFO. So how to use this software is actually very easy. So just research out HWiNFO and it will open up. So that is original sensors only, but for the first time user, it will show this. It will show this pop-up window. So you can pick all the mode here. So I'm using sensors only mode. So you click start and it will begin the program. So as you can see here on the right is all the sensors used during the CPU used by the CPUs, right, for the processor. So on how to record all the data of the sensor is very easy. You just see this at the bottom right corner. We have this sheet with like a spreadsheet like with a green plus symbol that is for the logging. So we just use the logging start symbol to keep and start recording all the data for a certain time frame. So we can start this logging, either we start it and then we play games while the HWiNFO is running in the background. That is to look or keep track of the performance of CPU during our desired program running. Okay, so once we click this logging start, it will pop up this window and ask to save the name, the file in the form of CSV. You can write file 1 or whatever. So, and once we click here, it will start logging. So how to do it? We click this, like for example in my place, we click logging start right here, and then okay, let's say name is Kali. We can save it, and we run it. We run a program which is SignBench. So now it's running the SignBench. So as you can see now, the apps of Maxon SignBench is now active. Okay, so once it's active, we can, because we already start the logging. Okay, so it automatically track all the CPUs, including the movement of the mouse. Okay, so now we just type HWiNFO again. Click yes. And can click to stop logging. Or you can also track here on real time the differences of the core and see here fluctuation of the core utility. Okay, so now we can stop logging. So how to access the file? Just open your file manager and then search for the file name you just created before. For my example, I use the Kali file. Okay, so now we have the Kali. So as you can see here, this is all the data for all the sensors. Okay, which is I run the SignBench benchmark for a brief while, and then I recorded the data. So how to extract the data? Okay, so how to extract the data is by just searching the column name. You can search, for example, for workload A, we need to find the thermal throttling. So we find thermal throttling, and then we bring us here. So since there is no value yes in the thermal throttling columns, we can now indicate there is no thermal throttling event occurred during the entire benchmark. So since there is no thermal throttling, meaning there is no clock frequency delta. So we don't need to calculate that. So aside from those two, we also need to find the dynamic power usage. during the workload A. So you just find package power. So as you can see here, this is the package power. This is the average power, but we want to look at the overall CPU package power. So this is it. So the dynamic power usage I use in the report is the one value with the maximum value of the package power. Okay, so there's a lot of different values, which is the different values is different for each interval of times. So we need to find the maximum values. Okay, so that is for workload A. So for workload B, okay, this is the file I use. We need to find the core utility. So you can either find core, just search in the utility, okay, and then it brings us to the core utility. So this is all the core utility. So from here, you can observe, analyze on your own whether there is dynamic thread migration or there is not. So as you can see here, all the values are more or less the same, with except for the core zero utility, because core zero is for the workload B, which is single core benchmark. So core zero is the single core used mainly. So as you can see, all the percentage is ranging from 100 above. But if you see this, suddenly the core utility dropped from 129 to 79. But there is no other sudden spike in other core utility, which means this does not indicate that there is a dynamic thread migration. So once with this fall, all other core utility also decreases, which means there is no observable or a very direct dynamic thread migration during the single core CPU benchmarking, right? So for the other COA terms that we define, which is the core temperature. And right here, as you can see, all the core temperature are almost the same value with minor differences between each other, ranging from 60 to 60, and you got here 60 to 60, 60 to 50, 50, 60, all are more or less the same value, which means there is no localized thermal hotspot occur during the single core CPU benchmark, which means that the CPU cooling system were able to spread or either spread the heat evenly and efficiently to avoid overheating of the processors. So that is all. Thank you.